Property number 3, electron affinity. Look, the concept of electron affinity is opposite to property number 2, ionization energy, but they are similar in the graduation through periods and groups. Look, electron affinity means the amount of energy released when the atom gains an extra electron changing into negative ion. So as you can see here, this process is an exothermic process and delta H must be negative. But what about the graduation? In the same period, the electron affinity increases when we move from left to right because the atomic number increase, atomic radius decrease, and the attraction force that we talked about it in last video, what decreases. So it's easier for the nucleus to attract a new electron. Unlike in the same group, as we go down, electron affinity decreases because as we go down, the atomic number increase, then the atomic radius increase also. So it's hard and more difficult for the nucleus to attract new electrons because the attraction force here decreases. But what about the exceptions? First of all, the electron affinity for nobles close to 0. They are completely filled elements with electrons. In addition, we have a disturbance in the graduation of this property in period number 2 in general for beryllium, nitrogen, etc. This is because the atom becomes more stable when the last sublevel is half-filled or full-filled, as we said in the last property. But now, what about the electron affinity of chlorine and fluorine? Look, the electron affinity of chlorine is greater than that of fluorine, although chlorine follows fluorine in the same group. Look, this is because the size of the atoms, which means the atomic radius. Here in group, as we go down, atomic number increase, atomic radius also increase. So here, the radius of fluorine is smaller than that of chlorine. So the new atom will suffer, the new electron will suffer a strong repulsive force with the 9 electrons already existing around the fluorine nucleus, which decreases the released energy due to consuming a part of this energy to overcome this repulsion force. Thank you.